Next concept is magnetic hysteresis. The word hysteresis means to lag behind, पीछे पीछे चलना. Who lags behind? Say if a magnetic material is taken, it is magnetized by applying certain current flowing into the solenoid. If current is flowing, it produces magnetic field. Say current is flowing in this particular direction, north pole is produced here, south pole is produced here. As you increase the value of the current, the value of the magnetic flux density produced in this material also increases. Due to solenoid, B is given by the formula mu 0 mu r n I. B is directly proportional to current. So initially when current is 0, B is 0, current increases, B also increases linearly, because the relation is linear, it's directly proportional. But after a certain value of current, as if you increase the current, the B goes into saturation. B goes into saturation. Saturation means what? If you again increase the current, there is no increment in the B is observed. जैसे मैं आपकी क्लास ले रहा हूं 1 hour, 2 hour, 2 hour, 3 hour, 4 hour. After continuous 4 hour attending the class, 5th, 6th, 7th, 8th, what happened? आपकी जो गेन कर रहे हो आप, वो कहां चला जाएगा? सैचुरेशन में. After 8 hours, it is fed up now. Fed up तो 1 hour में ही हो जाते हैं आप, लेकिन after 8 hours, sir, it is too much, sir, please. So what happened? This condition is called saturation. If I increase the time here, there is no effect, though there is no gain in the magnetic flux by the material. Number of lines of forces are so crowded. The lines of forces are so crowded, there is no room, there is no volume for another lines of forces. So this condition is called saturation. If you decrease the current now, the magnetic flux density also decreases, but it would not follow the same path, but it is following this path. When current becomes zero, slight magnetic field remains in this magnetic material. जब आपने करंट को जीरो कर दिया, still इस magnetic material में थोड़ी सी magnetic field बच गई. This is called residual magnetic field. बची खुची, residual मतलब बची खुची, residual magnetic field. Now, if I reverse the direction of current, what happened? Polarity reverses, south and north. But what happened? If you reverse the direction of current, first this residual magnetic field becomes zero, and then further if you increase the current in the negative direction, again B increases linearly, but very soon it goes into saturation in the negative side also. If you decrease the current, it will follow this path. Again, in the negative direction, some north pole, some south pole, some magnetism is remaining in this material. Retentivity, this capability to retain the magnetism is called retentivity of the magnetic material. Further, if you reverse the direction of current again, first this residual magnetic field becomes zero, then again it increases, it goes into saturation. Only in the first cycle it will obey this path, or otherwise फिर ये path खत्म, इसके बाद directly it will obey this type of cycle. If a magnetic material is alternately send the current and it magnetize, demagnetize, magnetize in reverse direction, demagnetize, demagnetize in reverse direction, it is placed in changing magnetic field. What happened? This is current. In magnetism, this is denoted as H, called magnetizing field intensity, जिससे आप मैग्नेटाइज कर रहे हो. सो व्हाट हैपेंड? H आगे चल रहा है, H जीरो हो गया, B जीरो नहीं हुआ, H नेगेटिव में आ गया, तब जाके B जीरो हुआ. H increases to maximum, field increases to maximum, then H becomes zero. So what happened? B lags behind H. This behavior of the material is called hysteresis. This portion capability to retain, remaining, it is called retentivity of the magnetic material. And to make this zero, the value of H required, it is called coercivity of the magnetic material. This graph is called BH curve. This area represents the hysteresis loss per unit volume. जैसे एक बकेट है आपके पास में, बकेट से आप पानी को इधर से इधर कर रहे हो, यू आर ट्रांसफरिंग द वाटर. आपने बकेट में वाटर को भरा, ट्रांसफर कर दिया, बकेट को सीधा किया, अब देखिए नीचे थोड़ा सा पानी बच गया. जस्ट टेक द क्लॉथ, जस्ट एब्जॉर्ब इट, साफ करिए उसको, छोड़, फिर दोबारा पानी भरिए, फिर दोबारा ट्रांसफर करिए, फिर सीधा करिए, थोड़ा सा बचा हुआ है, फिर उसको वॉश आउट करिए, उसको साफ करिए. हर बार वो थोड़ा थोड़ा पानी जो है वो लॉस में चला गया. दिस इज कॉल्ड हिस्टेरेसिस लॉस हियर. So hysteresis loss per unit volume is represented by this. For ideal magnetic material, the curve BH curve should be straight line, सीधा होना चाहिए. There is no saturation. Ideal student मतलब क्या? अगर मैं 50 घंटे भी आपकी क्लास ले लूं बैठ करके, तो you should be as fresh as in the first hour. लगातार आपको पूरा समझ में आ रहा है. There is no condition of saturation arises. So this is the straight line curve. This is for ideal. What is the relation between B and H? B is given by mu 0 mu r H. On x-axis H is taken, on y-axis B is taken, y is equal to mx. This is the equation of straight line passing through origin. What is the slope of this straight line? Slope means what? If this angle is theta, then tan theta is called slope. Slope represents what? Permeability. इसमें भी आप किसी भी पॉइंट पर एक टेंजेंट ड्रॉ करोगे. दिस इज एंगल थीटा. व्हाट इज द स्लोप ऑफ द BH कर्व? इट represents permeability of the magnetic material. Refer the booklet. Retentivity: when a magnetic material is magnetized and then demagnetized, then some residual magnetism remains in the material. This residual intensity of magnetization or magnetic induction or magnetic flux density is called residual magnetism or remanence or retentivity. This one, graph में ये value. For good magnetic material, it should be low. Dimensionally, it is equal to B. Coercivity: to destroy the residual magnetism, the direction of the magnetizing field H is reversed. The value of H required to destroy the residual magnetism is called coercivity. Dimensionally, it is equal to H. For hard magnetic material, means permanent magnets, coercivity force should be large. They should not lose their magnetism easily. That's why they are permanent magnetic material. एक टेबल मैंने बनाया. म्यू, रिटेंटिविटी, कोर्सिविटी, ससेप्टिबिलिटी एंड हिस्टेरेसिस लॉस में दो टाइप के मैग्नेटिक मटेरियल, सॉफ्ट आयरन एंड हार्ड आयरन. सॉफ्ट आयरन के लिए म्यू शुड बी हाई, retentivity should be high, coercivity should be low. They should lose their magnetism as just field is reversed. They should retain, but they should lose easily. Coercivity should be low, susceptibility should be high, hysteresis loss should be low. Permanent magnetic material or hard iron, mu should be low, retentivity should be low, coercivity should be high, susceptibility should be low, and hysteresis loss, it is immaterial because they gain permanent magnetism. There is no question of changing the value of magnetism. Importance of hysteresis curve, BH curve: it gives all information about the magnetic properties of magnetic material. First, permeability. Slope of BH curve, it decreases with increase in magnetic flux density. Here it is high, then it decreases like this. Second is coercivity, retentivity, hysteresis loss per unit volume, per unit cycle. It is equal to area of the BH curve. I have explained this. If the curve is plotted between I, intensity of magnetization, and H, intensity of magnetization, और H में अगर आप ग्राफ प्लॉट करोगे, so loss of energy per unit volume per cycle of the magnetization, it is mu 0 times area of IH curves. And slope of IH curve gives the value of susceptibility. important. So this is all about magnetism.